press, the Shenzhou 13 spacecraft returned to land, marking the success of the project. We are honored to be joined by Mr. Hao Chun, Director General of CMSA, Mr. Yang Hong, Chief Designer of the Space Station System of the China Manned Space Program, Ms. Huang Weifen, Chief Designer of the Astronaut System of the China Manned Space Program, Mr. Sun Jun, Chief Designer of the Space Station Mission at Beijing Aerospace Control Center, and Mr. Zhong Hong'en, Deputy Chief Designer of the Space Utilization System of the China Manned Space Program. They will share with us the progress on China's space station construction and answer your questions. Now I'll invite Mr. Hao Chun to give opening remarks. Ladies and gentlemen, dear friends from the press, good afternoon. It is a great pleasure to meet you all, and thank you for your support for China's manned space project. Yesterday, the Shenzhou 13 astronaut crew safely returned to the Dongfeng landing site and returned to Beijing in the afternoon. The Shenzhou 13 flight mission was concluded with a great success, and today, requested by the General Command of the Space Station, we'll take this opportunity to share with you the progress of the Shenzhou 13 mission and of the construction of China's space station, and also answer your questions. May I first briefly review the process of the Shenzhou 13 mission. On October 16, 2021, the Shenzhou 13 manned spacecraft was launched in the Jiuquan Satellite Launch Center and docked with the core module of the space station. The astronauts entered the core module, and when the astronauts stayed in orbit, they maintained the core module facilities and equipment as planned and carry out 2 extravehicular activities. They also conducted space science experiments and technological tests, gave 2 Tiangong classroom space lectures, and other educational activities. The Shenzhou 13 crew stayed in orbit for 183 days, setting a new record for the longest stay in orbit continuously for Chinese astronauts. The success of the Shenzhou 13 manned mission marked the conclusion of the key technologies verification phase. Right now, the 3 astronauts are in very good physical condition and are recovering in the astronaut center. The construction of China's space station is divided into 2 phases: key technologies verification phase and construction phase, with 6 missions planned respectively. The main objective of the key technologies verification phase is to explore and master the key technologies related to the construction and operation of the space station. Since 2020, 6 missions have been successfully implemented, namely the maiden flight of Long March 5B launch vehicle, the core module of Tianhe, Shenzhou 12 and Shenzhou 13 manned spacecraft, Tianzhou 2 and Tianzhou 3 cargo spacecraft. The success have been seen in all these 6 missions, and the staged objectives have been fully completed, laying a solid foundation for China's space station construction and long-term operation. Since the 18th Party Congress, the Party Central Committee, with Comrade Xi Jinping at its core, has paid great attention to the manned space project. General Secretary Xi Jinping personally visited the mission site many times and met with the representatives of the research and test teams. During the mission, General Secretary Xi Jinping also had a phone call with the astronaut crew. Keeping in mind General Secretary Xi Jinping's instruction and expectation, we made all out efforts to overcome the impact of the pandemic on the research and development and completed successes in a row. Our work cannot be fulfilled without the support of the central and state departments and local governments at all levels, as well as the theater forces. On behalf of the General Command of the mission, I would like to express our heartfelt thanks to all those who supported us and to all our friends from the media for your following and coverage. According to the plan, this year in 2020, we'll complete the construction of China's space station. 6 missions will be implemented. They are: in May, we'll launch Tianzhou-4 cargo spacecraft. In June, launch Shenzhou 14 manned spacecraft. And the crew will consist 3 astronauts, and they will stay in orbit for 6 months. In July, launch the Wentian Ask Heaven laboratory module. In October, we'll launch the Mengtian Dream the Heaven laboratory module. Then the 3 modules will form a T-shaped format, which is the basic format for China's space station, and completing the construction of the China space station in orbit. Then we'll launch the Tianzhou 5 cargo spacecraft and the Shenzhou 15 manned spacecraft. The Shenzhou 15 crew will consist 3 astronauts, and they will rotate with the Shenzhou 14 astronauts in orbit and stay for another 6 months. The year 2020 is the decisive year to complete the construction of the space station and also marks the 30th anniversary of China's manned space project. The completion of the construction of the space station and the completion of the National Space Laboratory is an important goal of the 3-step strategy of China's manned space project, and an important symbol of building China into a strong country in aerospace and science and technology. Facing this new journey in the new era, we're aware of the glorious mission and great responsibility. Will resolutely implement the important instructions of General Secretary Xi Jinping, meticulously prepare, organize, and implement the manned space project to ensure the successful completion of each mission in preparation for a successful 20th CPC National Congress with real actions. And now I'm ready for questions. Now we'll enter. The floor is open for questions. Please identify yourself before asking questions. Please. With CCTV. Yesterday, the astronauts returned safely to China, and you said this marked the success of the first phase, namely the key technologies verification phase. I wonder what have been achieved in this phase. Are all the goals met? Thank you very much. In my opening remarks, I said that the main goals of key technologies verification phase is to explore and master key technologies related to construction of China's space station. So far, the technologies have been successfly learned and mastered, which could be, and the goals could be divided as follows. First, a comprehensive verification of key technologies related to the construction of the space station. For example, we've mastered the support for astronauts' long-term in-orbit stay. Before this mission, the longest stay for astronauts was 1 month, but now it has been extended to 3 months, even 6 months. Also, regenerative environmental control and life support, large flexible combination control, flexible solar cell wing, and hand-controlled remote operation and docking. These have laid a solid foundation for the future construction phase. Second, the mission organization and command system was improved. We've entered a period of high density and normalized flight mission. So facing such challenges, in order to ensure success of the project, we further improved the mission organization and command system, established manned spacecraft emergency launch and astronaut emergency return, search and rescue mechanisms. Through the establishment and improvement of the mechanisms, we ensured the successes of the launch missions and the safe and stable operation of the space station and the safety of the astronauts. Third, we established an operation management system with Chinese characteristics. Different from the past, short-term and launch at intervals, now we've entered a period of long-term stay of astronaut in orbit, and this requires an all-time monitoring efforts of the command theater. We developed a combination of centralized and distributed space station operation control mode, as well as in-orbit operation management system. A ground-based flight control support system has been built and put into operation, laying a solid foundation for the following operation management of the space station. Fourth, we achieved high-level space utilization results and significant comprehensive benefits. We carry out space science research and utilization, focusing on containerless materials, high microgravity experiments, and completed a number of successful experiments. Adhering to the purpose of serving the nation and people's livelihood, driving the development of science technology, and enhancing comprehensive benefits, we this time put a number of experimental samples into the Shenzhou manned spacecraft. For example, aerospace, the seeds of aerospace breeding, microorganisms, electronic components, as well as some facilities aiming for deeper and greater experiments in the future. Also, we take this opportunity to launch a series of educational campaigns and programs for young people. For example, the space lectures, the Tiangong classroom, and also the spirit of the times and dialogue between Beijing, Hong Kong, and Macau youngsters. Through this mission, we have comprehensively verified, learned, and mastered the key technologies related to the construction of the space station and tested the functions of the systems in operating their tasks of the space station. We have also tested the capability of operating normalized and high-density tasks and programs. Next question, please.
谢谢主持人，我是红星新闻记者。
with Restar News. The design service life of China's space station is 10 years, and to ensure the long life and high reliability of the flight products is a serious test to each system component. The core module of the space station has been in orbit for nearly a year. How is its condition? Are the expected goals met or not? And there are many eye-catching components in the key technologies verification phase. For example, robotic arm. What role did it play in the mission? How is it performing?
I believe this question attracts a lot of attention. I would like to invite Mr. Yang to take this question. Thank you for your question. After the successful return of the Shenzhou 13 manned spacecraft, the core module and the Tianzhou 3 cargo spacecraft as an assembly are continuing to operate in orbit in a normal state, and operating parameters are stable. During the nearly one-year operation of the core module in orbit, all planned tasks were successfully carried out, and the rendezvous and docking tasks with 2 manned spaceships and 2 cargo ships were completed. The 3-month mission of Shenzhou 12 crew and 6-month mission of Shenzhou 13 crew, as well as special missions such as extravehicular activities, EVAs, robotic arm transposition of cargo crafts, and manual remote operation have been conducted. And many key technologies have been verified, including the physical and chemical regenerative life support, large-scale combination control, as well as large-scale flexible solar arrays. Assessment shows meeting the expectation results and some better-than-designed outcomes. For examples, during the stay of the 2 crews of Shenzhou 12 and Shenzhou 13, the regenerative life support system on the Tianhe core module provided a good living environment for the astronauts. Their metabolism needs were met with a high degree of efficiency on recovery of the condensed water and urine discharged by astronauts and reprocessing those into drinking water and oxygen. And the figure is over 95%, and water utilization efficiency better than 83%, both meeting the targets. Thanks to the said technology, the cargo craft needed to carry a lot less non-regenerative resources such as drinking water and oxygen for astronauts. Another example would be the flexible solar arrays and the power supply technology. Ever since it's put into orbit, it has been providing sufficient energy. And evaluation shows that the power generation capacity was nearly 10 kilowatts, exceeding the design expectations. And this thus provides sufficient energy for major tasks such as EVAs and rendezvous and docking. Another example would be EVAs. So far, 4 EVAs have been successfully completed, and the operation, installation, and maintenance of typical equipment such as EV, electronics, machinery, and pipelines have been completed. The whole process of exiting the module, EV support, and space-ground coordination meet the requirements, laying a solid foundation for the astronauts to install, repair, and maintain EV facilities during the long-term operation after the completion of the space station. At the current stage, we are also doing capability assessment to further tap into the potential of the core module and improve its quality and efficiency. The robotic arm played a great role in the entire phase of key technologies verification. It completed key tasks such as astronauts exiting the module transpositioning of cargo spacecraft and EV status inspection and performed flawlessly. EV operation of the robotic arm showed expected performance on its joint motion and positioning accuracy and other functions. The features of the robotic arm operating load showed that it has the ability to perform large load transfer tasks. At the same time, we also obtained kinematic model parameters of the robotic arm in the orbital weightlessness environment. This has laid a very solid foundation for future tasks such as robotic arm transpositioning, experimental modules, and EV payload maintenance. The core module has finished the tasks of verification and expectations have been met. Thank you.
Hi, I'm from Reuters. I have two questions. My first question is, will the COVID-19 outbreaks in China this year delay the completion of the space station by the end of 2022? And my second question is, how much has China spent on building the space station so far? And how much does China expect to spend in the coming months? Thanks.
请翻译一下。
您好，我是路透社的记者。我有2个问题。第一，新冠疫情的爆发呢，是否会推迟今年空间站的完工？第2个问题是，迄今中国在建造空间站方面花了多少钱？接下来预计还会花多少？谢谢。
好，这个问题我来回答。
Thank you very much for your question.
2020年新冠疫情发生以来啊
Since the start of COVID-19 in 2020, we followed the plan of the country
克服了很多的困难
to overcome the difficulties brought about by the pandemic and adopted several targeted measures
过程当中呢也
to offset the negative impact of the pandemic.
大力的支持和协助我们把疫情对工程的影响
We tried our best to minimize the impact of the pandemic to our project. So far, the progress is moving forward as planned, and our plan of construction will not be affected by the pandemic. The budget is moderate for China's construction of the space station. It is in line with the progress of China's national and socio-economic development. We used relatively small budget to achieve relatively rapid progress and achieved sustainable development and acquired a number of significant outcomes. Thank you. Next question, please.
谢谢主持人，新京报记者提问。
From the New Beijing Daily. In the field of manned spaceflight, the measurement and control communication system is often called the invisible kite strain, as the kite is getting bigger and there are more and more strains. What measures were taken to achieve precise measurement and control to ensure the stable operation of the space station?
I'll invite Mr. Sun to take this question. Thank you for your question. In the past 2 years, our main task has been to complete the assembly and construction of the space station. Since last year, through the 5 missions for practice and technology accumulation in the key technology verification stage of the space station, we have made breakthroughs and mastered the key technologies for flight control such as rapid rendezvous and docking, automatic mission planning, precise orbit determination and forecasting of spacecraft with complex configuration, and robotic arm control. We have built a nationally produced and stable flight control system platform and built a complete set of space station orbital flight control management system with distinct Chinese features. This shows that now we have acquired the key technologies required in this stage, and this means for this year's space station's in-orbit assembly and construction, effective support will be provided. While carrying out in-orbit assembly and construction, we will also continue to improve the efficiency of space station operation management, optimize the in-orbit support for astronauts, make the flight control system more automatic and smart, and on top of that, expand space sciences application experiments. All of these will help to improve the in-orbit efficiency of the space station and better harness its role as a large platform for space sciences experiment. The Shenzhou 13 crew set a record for duration of stay of Chinese astronauts in orbit in space. In the future, the Chinese space station and astronauts will continue to be in orbit for a long time. According to the mission planning and scientific experiment needs, our center is responsible for organizing and implementing in-orbit management of the space station, and we've taken measures to ensure the safety of the space station and astronauts in orbit. First, a ground verification system has been put in place. The plans for assembly and construction of the space station and in-orbit management of key flight control were developed with great care. More than 3,000 fault countermeasures were formulated. A large amount of simulation was organized, and we have put in place emergency flight control plans on the joint test environment formed between the spacecraft monitor and control stations and flight control systems before launch, for the purpose of ensuring reliable implementation of flight control by verifying the function and performance of those plans. Secondly, meticulous command throughout the process, in accordance with the principle of unified command and professional support. During the key control stages, experts from various fields were present to provide professional and technical support at the flight control site. During robotic control and EVAs that bear on major control and complicated in-orbit experiments, multiple systems cooperated with each other to closely monitor and evaluate the status and make on-site and science-based decisions on implementation of the various tasks to ensure their smooth implementation. And thirdly, precise monitoring and control was achieved. Relay satellites provided a wide range of telemetry and command coverage for the space station, including the sea, the space, and the ground. Every orbit was effectively monitored. We have built an automated flight control system, and automatic planning was made for all flight control events in orbit. We also used the digital space station for auxiliary health management and intelligently identified false conditions, and on a regular basis conducted physical examinations of the spacecraft to assess its status. Any abnormalities would be dealt with in a timely and effective manner. Relevant drills such as emergency evacuation of astronauts were carried out. All in all, safety has been front and center in the missions. Fourthly, security risks to the station were properly addressed. On top of full-time monitoring of the space station's equipment and astronauts' health, monitoring and early warning of the space environment and space collisions was strengthened, and necessary measures taken to avoid potential collisions. Since February this year, the orbit of our space station has been announced for the world for collision warning calculations for relevant entities. I would like to take this opportunity to express my gratitude to colleagues from all over the world for building a harmonious and safe environment for the Chinese space station. Thank you.
好，请继续提问。第一排吧，第一排这位女记者。
谢谢主持人。南方都市报恩施平记者提问，刚也提到了这一次在轨驻留半年，然后也是刷新了中国航天员单次
Just now you have mentioned there's a record set for the duration of stay, 6 months. What work has been done and what challenges have been met? Has there been support provided to them? And people are also paying attention to the health of astronauts. Can you give us some information on
大
that?
家关心的问题呢，我们请工程航天员系统的黄伟芬总设计师回答。
I'll invite Ms. Huang Weifen to take your question.
神舟13号飞行乘组飞行了183
The Shenzhou 13
圆满完成
crew
了各项任务。
flew for 183 days, setting several records when they stayed in orbit. When they stayed in orbit, they had 2 extravehicular activities, 2 space lectures, and completed 9 human factors engineering technology experiments, over 40 experiments covering space medicine, space utilization, and completed 80 items of in-orbit data collection analysis, conducted several rounds of maintenance, inspection, and monitoring of and protection of facilities when they stayed in orbit, and also completed in-orbit training and rehearsals and filmed a large number of images and video materials, and not to mention the education programs they conducted when they stayed in orbit. Overall, the 3 astronauts were in good physical and mental condition during the flight. They enjoyed very good cooperation and very fulfilling life and work. They have completed their tasks excellently. Right now, the 3 astronauts are back to the Beijing Space and Astronaut Center. They are in very good physical and mental condition and are now carrying out post-return recovery work. This is the first time for the Chinese astronaut to stay in orbit for 6 months. This is quite a challenge for the whole aerospace system. Before they took off, we give them a lot of intensive training before their flight and also some psychological preparation and emergency response training to the astronauts. At the same time, we give them very targeted healthcare measures. On the basis of the Shenzhou 12 mission, we improved the support, the in-orbit support for the astronauts. In terms of health protection, we optimized targeted healthcare measures in orbit, allocate additional drugs and medical equipment, optimized weightlessness protection exercise measures, make the exercises more convenient and fun, and we give the astronauts tailor-made exercise plans to make them more resilient and better prepared for their life in space, and also have targeted exercise on specific muscles to better adapt to the conditions in space. We also give them more fresh fruits, vegetables, and more personalized electrolyte drinks, and diversified the psychological support for the astronauts to better stay in orbit. And secondly, the astronauts' life support was also strengthened. We give them more styles of clothes to wear in space and give them better daily necessities and hygiene products, and also give them more entertainment projects and options. At the same time, the astronauts in orbit work protection was also strengthened. The guidebook of astronauts' operation was specified, and put into and revised to give them dynamic updating of the astronauts' work plan, timeless assessment of their workload. The project has been successfully concluded, which is a clear proof of our work, and the work and the progress we achieved in the Shenzhou 13 mission will lay a solid foundation for subsequent missions, accumulating richer information and experience for future missions. Next question, please.
您好，俄通塔斯社记者提问。中国空间站已经
From
确定
TASS,
了20左右个
China's
合作国
space
家
station has
包括俄罗斯
identified about 20
今年
cooperation
年底之前
countries,
空间
including
站
Russia.
将会
By the end of
正
this
式
year,
建成。
the China space
从
station will
明
be
年开始
completed
就会
and
正
enter
式运行。
into
请问
operation
在
next
比
year.
较复杂的国际
I wonder
形势下
if
空间站是否
normal
可以
international cooperation could be
推进
advanced,
正常的国际合
considering
作
the
在这个
complex
领域
international situation.
是否会发生一些
Will
障碍
there
或者
be
问
any
题？
problems
请
and
问您
obstacles?
有什么
What
期待
is China's
或者考
expectation?
虑？谢谢。
Thank you.
这个问题我来回答。
I'll take this
探索未知
question.
宇宙，
To
发展
explore
航天技术
the
是人类
mysterious
共同事业
universe and
离
develop
不开各国
aero
通力合
technologies
作
is a common pursuit of humanity.
纵观世界载
It
人
will
航
not
天
be achieved
发展的
without
进程
cooperation
国
of
际合
countries
作
around the
是推动
world.
载人航天
And
实现
international
各国实现
cooperation
发
has
展的历
been
史潮流。
a historical trend
中
for
国
the
在航
development
天的
of
发展呢，始终坚持
space programs.
和平、
And
和平
in
发展、
China's
平等互助、
development of manned space projects, we have been guided by the
我们与世
principle
界
of
上多
peaceful
个
use,
国家和
equality,
组
mutual
织
benefit, and
签署
common
了合作
development.
协议，
We have signed
开展了一系列的
cooperation
合作与
agreements
交
with
流，
many
实施
countries
了一系列
and
的合作
carried
项目，
out
取得了一大片丰
multiple
硕的
cooperation
合作成果。
projects and
后
made
续呢，
a lot of
我们
outcomes.
还一定会
Going
在这个
forward,
原
we
则
will
下，
continue to be guided
与世
by
界
that principle
所有
and
致力于和平利用
carry
外
out
星的国
cooperation
家
with
开展
all
更深
countries
入的交流与合作。
that are committed to
我们愿
peaceful
意把
use
我
of
们
the
的
outer
空间站
space, and we
打
are
造成
ready and willing to
推
build
动
China's
构
space
建人
station
类命运
into
共同体的一
one
个
that
造平台，
contributes to
和
building
各国家
a community with a
的
shared
航天
future for
员、
mankind,
航天科
and
技队伍一
we
起不断的
are ready
探
to
索
work
跨越
with
宇宙，
the
造福人类。
astronauts
谢
and
谢。
agencies of all countries to contribute to humankind by exploring the universe.
第三排。
谢谢凤凰卫视记者提问。刚才
With
好主任
Phoenix
介绍了
TV.
下半年我们在
Just
7月
now,
和11月计
you
划
have
发射
mentioned
问天
that
和梦天两个
Wentian and
实验舱
Mengtian
将会完成
modules
航
will
天员
be
的载荷建
launched
设。想问一下
and
梦天
completing
和
the
问天
building
两个
of the
实验舱
space
现在的
station.
研发进展怎么样了？
What
实
is
验舱
the
未来
current
将会主
stage
要发
in
挥
their
哪些作用？
development? What role will they play?
关于这个实验舱两个实验舱进展，请杨红总设计回答。
好，感谢你的提问。
Thank you for your question.
空间站建成以后呢，
After completing the
两个实验
construction
舱
of the
将
space
是航
station,
天员的主
the
要
two
的工作
laboratory
场所。
modules will be the main
在两个实
workplace
验
for the
舱里呢
astronauts.
都可以开展舱内
And in both
密封
modules,
舱内
they can
和
carry
密
out
封舱
sealed
外的
in-modular
空
and
间科学和
extravehicular
技术实验。
space
这
experiments.
两个舱里面呢，都配置有
And the two modules
科学实
are
验的
both
有效载荷机
configured
柜
with
还有舱
in-modular
外呢
load
配
testing
置了
cabinets
载荷
and
的安装平台。
extravehicular
然后我
load
们
installation
空间站
platform,
呢，平台也提供了
and also
信息
equipped with
供电
information and
和
power
散热
support
等
and
支持和
heat
保障的措施。 可以开
dissipation
展空间科学
facilities,
空间材
making
料
the two
空间
modules
医学
available
以及
for
空间
space
探测
materials,
等
space
多个
medicine,
领域
space
实验。
exploration, and other
下
areas
面呢
of
我就简要介
experimentation.
绍一下这两个舱的特点。
The
首先，
characteristics
温
of
田
the two modules are as
温田
follows.
实验舱呢
First,
是配置
the
了与
Wentian
核心
laboratory
舱
module,
一样的
Questing for
航
Heaven.
天员的生活设施。
This
这里
module
头
is
包括
configured with the
3个
same
睡眠
astronaut
区、
living
1
facilities
个
as
卫
the
生区
Tianhe
和
core
厨
module,
房
including
等设
3
施
sleeping
可以保
areas,
障
a
航天员
washing
的生
area,
活。
and kitchen and
它还
other
可以与
facilities.
核心舱一起
And together with the core
来
module,
支持
the
两
two
艘
modules
载
can
人飞
support
船
the
停
life
靠的
of
时候
6
6名航
astronauts
天
during
员
the
的生活。
rotation of the two manned
另外
spacecraft.
呢，还配置了一个小型的机械
It
臂，
is also
它
equipped
既
with
可
a
以
small
单独使
robotic
用，
arm,
也
which
可
can
以
be
跟
used alone
核
and
心
also
舱的
used in
机械
combination
臂
with
来
the
进行组合
robotic
使
arm
用，
in the core
来
module.
共同完成航天员的
And
储
the
舱
two
以及
arms
舱
can
外实
together
验设备的
complete
照料、巡
the
检等
maintenance
任务。
inspection of the
另外的话呢，
extravehicular
在
and
温田实验
in-cabin
舱还配
facilities.
置了一个航天员出舱
In
用的气
Wentian
阀舱。
module, there's also an airlock cabin. And the core module and the airlock cabin will be used for astronauts to conduct extravehicular activities. And there will be a backup airlock cabin in the core module, not cabin. So when the functions of the core module failed, the Wentian laboratory module will be the main module to conduct experiments to increase the reliability of the space station. Whereas Wentian laboratory module, there is an airlock module for cargo and an extravehicular experiment platform. So in the future, the facilities for extravehicular experiment could be transported by cargo spacecraft, and then through this airlock cabin in the Wentian module, the facilities can be stored on the extravehicular installation platform to conduct extravehicular experiment. So far, the two laboratory modules, their experiments are moving smoothly. The Wentian experiment laboratory module has been completed in Tianjin and will be transported to Hainan launch site by the end of April. And the Wentian module has completed in Tianjin and is under test. In the future, it will complete a thermal test and regression test. It is also moving smoothly as planned. Next question, please. With Guangming Daily, what results have been achieved of the space utilization system in the key technologies verification phase, and the Wentian laboratory modules are scheduled to launch this year? What will be the follow-up arrangement for the system?
I invite Mr. Zhong to take this question. Thank you for your question. During the nearly 1 year in orbit flight test of the core module, the newly developed payload on the space application system has been running well and stably and in close coordination with related systems. High-quality in-orbit test and application data has been obtained and fruitful outcomes made. First, the new generation integrated space-ground system solution was applied, including the shared support facility solution and the development of major scientific facilities, as well as low-latency information transmission solution. This has thus laid a solid foundation for experimental module construction. Second, for the first time, it means high-reliability, large bandwidth optical fiber backbone network was put in place. Large capacity distributed data storage and data processing was also available. And we have also made breakthroughs in the scientific experiment cabinets. A third, the container-free laboratory cabinet was China's first and the world's second experimental facility of the kind in orbit. In comparison with the first one, it has higher indicators and stronger experimental capabilities. It has successfully completed experiments on various types and batches of samples. The heating temperature reached above 2000 degrees Celsius. Various novel phenomena had been identified, and in-depth research has been carried out. Fourth, the high microgravity scientific experiment cabinet pioneered the double-layer vibration isolation scheme of magnetic levitation and jet levitation, which achieved a high microgravity level 2 to 3 levels of magnitude higher than the space station platform as low as 10⁻⁷ squared g, reaching internationally advanced level. It provided necessary experimental conditions for cutting-edge research, such as relativity and gravitational physics. Fifth, for the first time, latency of the space-ground closed loop for application support was shortened to within 2 seconds. And an experimental mode for parallel comparison between the digital twin model and the physical image was established, which effectively supported in-orbit scientific experiments. Going forward, we will continue to carry out scientific experiments in the core module, including the use of container-free materials experiment cabinet, and they will finish in-orbit construction, launch site test, and launch testing. 14 scientific cabinets have been installed. Each and every one of them is a space laboratory. And outside of the module, multiple EV points and EV platforms have been installed. And the Sky Survey telescope has also been installed as a flagship facility. This will enable us to carry out research on space life sciences, aerospace and geosciences, and new space technologies and applications. Over 100 research plans will be carried out, covering over 1,000 projects. This will enable us to study the origin of life and other cutting-edge areas. Major progress is slated to be made, and on space materials science, life science, microgravity, fluid physics, and other major directions, we are expecting progress to be made. This will advance China's relevant research to reach internationally advanced level.
第一排吧。
谢谢主持人。新华社记者提问。
Was Xinhua News Agency. With the completion of the verification stage, the construction will further proceed. Can you share with us what is to be expected after the completion of the space station?
Thank you for your attention to the manned space project. After the completion of China's space station, the project will turn into a more than 10-year of utilization development phase. Our plan is to launch 2 manned spacecraft and 2 cargo spacecraft every year. Astronauts will stay a long time in orbit to conduct science experiments and tests and maintain the space station. To further enhance the comprehensive capabilities of the project, a new generation of manned launch vehicles and a new generation of manned spacecraft will be developed, of which the new generation of manned launch vehicles will be reusable, and the new generation of manned spacecraft will be able to take up to 7 astronauts and have stronger loading capabilities. And also, we are developing the extending modules and cabins of the spacecraft to conduct more experiments and provide better living conditions for the astronauts. In this 10-year-long period, we'll also use the in-module scientific experiment cabinet and the extravehicular load platform to carry out larger-scale space science and research and new technology experiments involving space, life science, and human research, microgravity physical science, space astronomy and earth science, and new technology, new space technology, etc. Next year, we have the plan to launch China's first sky survey space telescope to carry out sky survey observations. And we hope that we'll carry out cutting-edge research in the formation and evolution of the structure of the universe, dark matter and dark energy, exoplanets and solar system objects. There might be a number of major innovation outcomes. We'll also actively explore new models of commercial human space flight and introduce commercial cargo and other social forces to continuously improve the general benefits of space station operation management. Throughout the history of the world's space development, the moon has always been a very favored destination for manned space flight towards deep space. And China's manned space project will gradually move from near Earth to Earth-Moon space and then to deeper space. And in the process of building the space station, we have also carried out key technology research and discussion of manned lunar exploration. I believe that the 1,000-year dream of the Chinese nation for moon exploration will become reality in the future. Next question, please.
这位吧，第二排。
好，谢谢。总台 CGTN 记者提问。
With CGTN, after the successful return of the astronauts, there is a growing interest of the missions that follow. It is understood that there are 2 batches of 6 astronauts to carry out missions this year. And what are the missions for the Shenzhou 14 and Shenzhou 15 astronaut crew? Any preparations have been done?
I'll invite Ms. Huang to take this question. Thank you for your question. According to the task arrangement during the construction phase, the crews for the 2 manned missions in this phase have been selected. At present, the astronauts for Shenzhou 14 and 15 missions are in good condition and actively carrying out mission training and doing various preparations. Both crews will be in orbit for 6 months, and the crew will be rotated at the space station for the first time. That means 6 astronauts will stay together at the same time for 5 to 10 days in the station, and that will be very big challenges for the system. The crew of Shenzhou 14 will cooperate with the ground to complete the assembly and construction of the space station, during which a single module assembly will in time become a 3-module assembly. In this process, 9 formations of the assembly, 5 rendezvous and docking missions, 3 separation and 2 transposition missions will be done. For the first time, they will go into and stay in the Wentian and Mengtian modules and form a manned environment. They will work with the ground to do testing on the 2-module assembly and 3-module assembly and other tests. They will also, for the first time, use the airlock to carry out EV activities, complete the unlocking and installation of 14 cabinets in the modules. The crew of Shenzhou 15 plans to carry out multiple EV activities to assemble, test, and debug the payload equipment in the module, control robotic arms to install payload facilities outside the module, manage and maintain the space station assembly, which would be 3 modules and 2 ships. Both crews will carry out scientific events for educational purposes and other public activities. And according to plan, they will also do dozens of experiments and engineering tests. They will collect flight control data and carry out a large amount of work on platform inspection phase. We have made and done targeted training for the crews falling under 8 categories, so that all the astronauts will be fully prepared in terms of their energy, physiology, their mental state, among others. And we have carried out training on the following aspects. First, training on the setting of the stationed state of Wentian and Mengtian modules and the normal operation of each subsystem, their maintenance and repair, and on station and supplies management. Second, for robotic arm verification and verification of EVA through exiting airlock, training on maneuvering the robotic arms, the simulated weightless water tank, EVA virtual reality, low-pressure environment were conducted. Third, for the remote operation of rendezvous and docking and manual operation of experimental modules. And fourth, we have also carried out the support training for them to stay in the mission. And fifth, we have carried out a lot of training for them to control the platforms. And over 100 engineering developing tests and experiments, they have been fully involved in the development of the manuals, and we have been increasing their ability to really do the work on the site. In addition, we have also strengthened personalized training and health support and arranged for the two crews to communicate with the Shenzhou 12 and Shenzhou 13 crews many times. We will also further improve on the basis of the Shenzhou 13 mission. The astronauts will enjoy better long-term flight and in-orbit residence support to live healthily, work efficiently, and complete their flight missions successfully.
最后一道题吧。第二排，
谢谢。封面新闻记者提问：我们知道中国载人航天工程经过了30年的发展，今年将完成空间站的建造，进入到
After 30 years of development, the space station of China will be fully built this year. What role has such technologies played in improving people's lives? Thank you for your question. The manned space program is truly rocket science, but it also touches people's lives. As well as developing itself, it has been promoting the development of certain industries and economic and social development, so it is closely connected to people's livelihoods. One, on advancing development of science and technology, as the most complicated area of science and with the most intensive technology and innovation. It has been witnessing a lot of technological innovation outcomes, and the technologies have been applied in other areas. For example, the control of combustion heat transfer system of liquid rocket engine has been able to upgrade the industry of gasification of pressurized pulverized coal and domestic waste disposal. It can also effectively increase efficiency of hydrogen fuel cells. The manned spacecraft and stations for the control measurement, image processing, components and other technologies related to that are also able to drive upgrading of industrial smart control systems. The heat-resistant technology of manned spacecrafts have been transferred into insulation materials. We have all watched the splendid Beijing Winter Olympics. Actually, outcomes of the aerospace technologies were everywhere at the Beijing Winter Olympics, from the opening ceremony to the training gear of athletes. Second, on advancing economic development, China's manned space program, after 30 years of development, has witnessed over 4,000 of its technologies being transferred into a wide array of sectors in the economy. For example, microelectronics, machinery, manufacturing, seeding, have all contributed, seen the outcomes of aerospace technologies. The seeding on manned space ships have contributed directly to a growth of 200 billion RMB, and it has been used in food processing, culture equipment, and biopharmaceuticals, contributing to economic development as well as food security and environmental protection. 3. On improving people's lives. We all know that the supplies that we are very used to, instant food or diapers, they come directly from the transfer of their aerospace technologies. And now more and more technologies will be used in livelihood areas. For example, using the space proton crystallization studies can help with the development of drugs for osteoporosis and muscle atrophy, and the development of new materials on space programs can also be used to improve people's livelihoods. In the future, China's space station will also witness research and experiments on space life science, materials science, and fluid physics. And a lot of breakthroughs will be made. On top of that, I believe more technologies of this kind will be transferred and contribute to economic development and people's livelihoods. Thank you very much. This concludes today's press conference. Thank you.